So today we're going to be doing an example to help you create your poster on unit lead solutions. So that's using conversion factors to aid you along in finding a solution to a word problem. So the first thing I want to do is read the problem aloud and identify important information and what conversion factors I need. So we have, if Scout is driving at 35 miles per hour and she's 200 kilometers from her house, how many minutes will it take her to get home? How many days? So we've got 35 miles per hour, and we can rewrite that like our conversion factors, 35 miles per hour. And then we have kilometers here. So I see that we've got miles in our original information, and our conversion for miles would be 1 mile equals 1,609 meters. And 1 meter equals, 1 kilometer equals 1,000 meters. Some other important conversion factors we're going to need would be 1 hour equals 60 minutes, because we have hours here and we want to get minutes. And then also days, and to go from hours to days, you've got 24 hours in one day. We're also going to be using an equation in this problem towards the end. And that equation is distance equals rate times time. So let's start out with our original information. Scout is driving at 35 miles per hour. So we want to convert miles into kilometers, and we want to convert hours into minutes. So to go from miles to kilometers, we need miles in the denominator so that the terms cancel out, and we use the conversion factor here. And then we're going to go from meters to kilometers. So we want meters in the denominator, and that's our next conversion factor. Now we're in the kilometers like we wanted, but we're still in hours. So let's go ahead and convert our hours into minutes. So this time, it's going to be in the numerator because we want our hours to cancel out. They've got to be on opposite sides of that divisor. And then 60 minutes. So we use this factor, and this factor already. So this turns out to be about 0.94 kilometers per minute. And you can see here, miles and miles cancel out, meters and meters cancel out, and hour cancel out. So what we're left with is kilometers per minute. This isn't quite what we were looking for because we want to find out how many minutes it will take her to get home. So what we actually are going to do next is use that equation, distance equals rate times time. Now, minutes is a unit of time, so we're going to rearrange this equation to have time on its own. So time is equal to distance over rate. And rate is just another word for speed. So let's go ahead and plug in the information we have. Our distance is 200 kilometers. Our rate is 0.94 kilometers per minute. Now this conversion here is a little bit more difficult to see, but we can use some rules of fractions to help us out. So when you divide by a fraction, you actually want to multiply it by its reciprocal. So I'm going to take kilometers per minute, which is in the denominator, and I'm going to flip it over and multiply this fraction by it. So now you can see that kilometers and kilometers cancel out, and we're left with minutes. So this gives us about 212.8 minutes. Now, the next part of this problem is how many days will it take Scout to get home? So let's go ahead and convert minutes into days. So I've got 212.8 minutes, and I want to convert that back into hours. So we have 1 hour is 60 minutes. Again, minutes is in the denominator because originally it's in the numerator and we want them to cancel. And then down here, I've got 24 hours because I want hours to cancel, and that's equivalent to 1 day. So once you plug all of this stuff in and calculate, you'll end up with somewhere around 1.48 days. So again, we've got minutes canceling with minutes, hours canceling with hours, and we're left with days. And that makes sense if you look at it and think, okay, well, 212.8 minutes, that's definitely not an entire day. So if you have any questions, please feel free to ask me, and I hope this helps out on your poster creation project.